Hello Year 10. So this is video number 2. It is the harder versions of all of the possible things that may come up in the exam. It's not everything, but it's just a good variety. So in the same order as last video, we're going to start with surface area and volume. If you want to pause this video and give these a go on your own, definitely. Otherwise, let's jump into it. So as surface area, we find that, I always tell you that we want to map out all the areas we're going to find. We've got a cube here with a cone on top of it. We're going to paint this, let's say, another piece of playground equipment that Miss Murray has created. So if I'm going to paint this, let's think, I got a cube. Cubes have 6 sides, but one of the sides has that big cone sitting on it, which means I've only got 5. Well, no, let's think of it as 6 for now. We just got to keep in mind, though, of that cutout from where the cone is sitting on top of it. So there's 6 of them, and they've got dimensions 5 by 5. So that's the first thing. Then I've got my cone. So I think, okay, then I've got a surface area of a cone. And I go to my formula list. What does Miss Murray have here? Surface area of a cone, pi r squared plus pi rl. And she's been nice enough to give me the length as 9. And if the diameter of the bottom of that cone goes the whole way across that square, diameter is 5, so the radius is 2.5. All right, now there's my nice plan, but I'm going to add in here some other notes. Let's think about this cone that I'm going to find the surface area of. I'm not going to be painting the bottom of that cone there, which means I don't want the pi r squared part of my formula. I only want the pi rl, because the pi r squared part is going to be that circle on the bottom. But what I've also got to do, I'm not including it when I'm painting the cone, but I also need to not include it when I'm painting my cube. So what I have to do to the answer of my cube is subtract a pi r squared, because I've got to subtract that circle that was counted for when I do the surface area of 6 squares. So there's my nice little map out. So if I start working that out bit by bit, so my 6 squares work out to be 150 meters squared. If I now do my area 2, or go to my cone, I'll come back to the other part. Pi rl is all I need for the cone. Gives me pi timesing by 2.5 timesing by 9. Now, one of 2 things I want here. Because you're not finished with the answer, I'm going to leave it in terms of pi. Otherwise, if you did a decimal, I want quite a few decimal places written out. Either way, doesn't matter. Okay, but then don't forget the area of the circle that I need to subtract off, which we talked about up here, is just going to be pi lots of 2.5 squared. So now my total surface area is going to be 150 plus 22.5 pi minus my 2.5 squared, which becomes 6.25 pi. Put all that in your calculator and let's go 2dp. And there we have it. Hopefully you got 201.05 meters squared. Okay, let's go over here now, volume. So another strange, we call these composite shapes, where we've got to think about now filling this with water. So what do I have? I've got a rectangular prism and half a cylinder. So what do? One at a time. Volume 1 equals a prism, area times height. Doesn't matter if you do the front of the shapes or the side of the shape as the area, but you'll get the same answer. So it's 10 by 2 is my area, times it by 2 the depth, which will give me 40 meters squared for the area volume of the rectangular prism. And now the volume of my cylinder, well, cylinder we class as a type of prism, but because it's half of a prism, it's half area times height. and the area is going to be that circle, half of pi r squared. So half timesing by pi timesing by my radius will be 1 squared, and then times it by the big height of the cylinder, which will be that big long line, which is 10. If I clean that up, it's going to just give me 5 pi. Because 10 times a half gives me 5, 1 squared is 1, so 5 pi. So the total volume is going to be volume 1 plus volume 2, which equals 40 plus 5 pi meters cubed. And if you put as a decimal, so you should get 55.71 cube meters to 2 dp. Okay, let's have a look at a backwards midpoint question. We did one of these on the board in class. I want you to pause the video and give it a go. Otherwise, what you should do, start by subbing everything into the midpoint formula where it belongs. What it's saying is the point 24 and whatever AB is has a midpoint of -1,6. So my answer is -1,6. So the answer goes on the end, and now x1, y1, x2, y2, doesn't matter which one's 0.1 and which one's 0.2. So I get 2 plus x on 2, comma, 4 plus b, A it is, 2 plus a, 4 plus b on 2. Now this is where a lot of people get stuck, but just think of it as 2 plus a on 2, that answer should give me -1. So there's my first equation. 2 plus a on 2 should equal -1. And my second equation is that 4 plus b on 2 should equal 6. So 4 plus b on 2 is meant to equal 6. When you solve those two equations, you get your A and B answers. So if A is 0 and B is 8, then the point AB is 0, 8. And you could always check that then and put it into the formula and make sure you get an answer of -1,6. Next, we're going to look at just some sketching some harder parabolas. These don't really get much harder than this, okay? So let's see, pause the video if you like, give them a go. First one, shift it into the -3 direction, but then down 4. So I'm going to start by labeling -3, -4 as my vertex. I know that it's going to look something like this because it's a smiley face parabola because the x is a positive x, it's going to be squared, which tells me I've got a few things to find, some x and y intercepts. If I need to find a y-intercept, I make x 0. So y equals 0 plus 3 squared minus 4. 3 squared is 9 minus 4, so I get y equals 5. That's an interesting point there. I'll come back to that. Now if I want to find the x-intercept, I will make y 0. So 0 equals x plus 3 squared minus 4. And now this is an equation, I want to find x. So bring the 4 over. Now I'm going to square root 4, which gives me plus or minus 2. So I got plus or minus 2 once I bring the 3 over. So my x values are plus or minus 2 minus 3. That's going to give me 2 answers, which makes sense because I got 2 x-intercepts that I need to find here. If I've got positive 2 minus 3, that gives me -1. If I've got -2 minus 3, that gives me -5, which tells me my drawing is actually pretty way out of scale, which is always why it's handy to have these x and y intercepts found, because what actually is happening is it's more like this as a parabola, where the y-intercept was at 5 and my x-intercepts are at -5 and -1. So you can see there how scale comes into it more. When you know your x and y intercepts, you definitely get more of an understanding of what that graph looks like. All right, And the last one, we're shifted over into the +2 direction, and then up 2, which tells me my vertex is going to be at 2, 2. It's going to have no x-intercepts, but it will have a y-intercept eventually. So up here somewhere. So I could find my y-intercept by making x 0, which gives me 6. So my y-intercept is at 6. Okay, now let's look at parabolas with 2 x's. So this question's got 2 x's. I want you to have a go at doing your x and y-intercepts to start with. It's going to be messy. This one is not pretty. See how you go. So, start by solving my y-intercept. I make x 0, so that's all I've said there, that y-intercept at x equals 0. Subbing that in, you get a y-intercept of -4. X-intercept at y equals 0, subbing 0 in where y is. What do I have? I have a quadratic that I need to solve. What do I have though? I have a non-monic. A non-monic quadratic. Oof, not pretty. Times it over. I'm going to have my 2x and 2x. What times is to give me -8 plus is to give me 7, gives me 1 and 8. +8, -1 will give me a +7. Now what do? Because I times by 2, I divide by 2. I divide one of them if I can, which I can, which leaves me with 2x minus 1, x plus 4. Now solving both of those, I get 2x equals 1, so x equals 1/2, and x equals -4. So there's my x-intercepts. All right. What about our axis of symmetry? Axis of symmetry has a formula of x equals minus b on 2a. Let's see what I get. Minus b gives me -7 on 2 lots of a. How messy is this? -7 on 4. Not pretty, so I'm just going to make it a mixed number just so I can get an understanding of whereabouts that's sitting. That's -1 3/4. So at least I know roughly where that's sitting. So my vertex now, sub that really ugly number and use as many brackets as possible when you're doing this. Make sure your squared's on the outside of the brackets. And if you are careful enough with your negatives of subbing that in, you should get an answer of -341 on 24, which is equal to -14 and 2.0, or -14 and 5 on 24, or if you did a decimal, -14.20833. Any of those answers, perfectly fine. Preferably I like the middle one because it tells me roughly where I'm at without having to round, which tells me my vertex is -1 and 3 on 4, comma, -14 and 5 on 24. Now we get to draw this amazing thing. I always start my drawing with all the intercepts. So we've got -4.5, and I've got -4 as my y, and I've got -1 3/4, -14 somewhere here. So if I draw all of that together, there I have my parabola. Tough one. All right. Let's have a look now. This one is just a completing the square. So pause the video, give it a go if you like. Otherwise, if you had trouble with you completing the square in your formative, maybe pay close attention here just to avoid those little errors. So what do? I put a plus box on the end of the x's, and then a plus box on the end of the y's. I put all the constants onto the other side. But I also have to plus those boxes onto the other side. Now, what is box? Box is equal to b on 2 all squared. So b is that middle number there. So negative 4 on 2 all squared gives me 4. Put a 4, put a 4. And the other one, negative 2 on 2 all squared gives me 1. Put a 1. Now by doing that, this is where a few people made a mistake. Now by doing that, I can create this formula. If you have trouble thinking of or working out that perfect square number, it is always just b on 2. Okay? So a few people can do your perfect square and do the plus box exercise part, but if you then need to then put it into your perfect square formula to factorize, if you can't think of that number, it's just b on 2, which is where people get confused because some people are doing b on 2 squared in there, but it's just b on 2. So b on 2, thinking about just b on 2, I'm going to have negative 2 because 4 on 2 is negative 2. Y, what's b on 2? Negative 1 equals, what do I get on this right hand side? Negative 1 plus 4 plus 1. Oh, this one's nice. That was by a pure fluke. So negative 1 plus 4 plus 1 gives me 4. Here's my circle. So here I have a center. What do? Take the opposite signs. 2, 1. Radius, 2. Let's draw it. 2 out, 1 up. It has a radius of 2, so it's going to hit the axis here, below. There's my rough circle. That's not good circle at all. Now, when you draw your circle, I do prefer it if you put your radius of 2 on there as well. Okay. Nearly there. We're going to finish with some difficult hyperbolas. Pause the video, give these a go if you like. Otherwise, let's have a look. The first one, it's a negative hyperbola. The negative 4 just means it's a steeper hyperbola. Okay, so that it just makes those, they're never pointed, but they're closer to being pointed. All right, so I've got a negative hyperbola. It's pretty sharp. It gets shifted into the negative 1 direction, and then it gets shifted down. Okay. If it gets shifted in the negative 1 direction, my asymptote will move over to negative 1. If it gets shifted down to negative 2, then my asymptote here will move down to negative 2. And now all I have to do is draw my negative hyperbola in those sections. No, I don't want to do that. Okay. I think we're doing too hard of maths for my laptop to handle. So, anyway, looking at my asymptotes, I've got to draw now a negative hyperbola that's pretty sharp in these sections. Let's do my best. There we go, something like that. I'd be really impressed if you can then find your x and your y-intercept of that there. I'll leave that for you to do though. The other one though, we've just got plus 1, so it's shifted up 1. And minus 2, so it's shifted into the positive 2. And it's a positive parabola, so it's in the positive, and it's pretty steep as well because of the 3. Not as steep though as that last one, but let's see how that drawing looks. And again, well done if you can then work out your x and y intercepts. Okay, there I have the harder lesson. Okay, let me know if you have any questions about this, but otherwise it's a really nice summary of the easier and harder parts of what can be in your exam.